March 22nd is World Water Day, and each year there is a theme, and this year the theme is groundwater. And so we're making the invisible visible. And that's why, as the Project WET coordinator for West Virginia, I wanted to call in 2 people that have careers in groundwater so that we could showcase how groundwater is important here to West Virginia.
With this year's World Water Day topic being groundwater, making the invisible visible, we thought it'd be better to use a model to simulate what goes on underground. First off, we'll talk about some of these points. That absorption field ties into a septic tank. So your wastes from toilets and your bathtub sinks go to your septic tank, and the absorption field is the area where the soil absorbs those wastes and treats it before discharging. We have the different layers. The fine-grained is like the sand, and then there's a coarse wedge. We have a confining layer, and confining is like a seal or a barrier between the different layers that prevents the migration from being as quick. And artesian means there's pressure between the confining layer and that layer. So when you put a well in it, the pressure allows you to be able to draw the material up. This shows how the surface and the ground are connected, and the groundwater and surface water are connected.
Well, groundwater is important to West Virginia in many different ways. Mainly, a lot of people get their drinking water from the ground. My grandma, for instance, still pulls her water out of the ground. And it's important for us to realize how groundwater moves underground so that we can understand if we are polluting it or if it's a clean drinking source or not. It's also a very important part of the hydrological cycle. And so anytime we have a low water or it hasn't rained for a while, a drought, some people would call it, we still have a lot of base flow in our rivers because of that. So it's important to understand how groundwater is connected to our rivers, how it's connected to us in drinking, how it's connected to springs and lakes, and all the water sources that we have on the surface here in West Virginia.
Here we'll show you an example of how the groundwater and surface water are interconnected. We have a lake level here marked in red, and we have wells that are near this lake which can actually be influenced by the lake levels. We also have a well over here and a water column. We're going to reduce the groundwater level within this model down, and you will actually visually see how the lake level will drop down with it. We're going to drop the water level in our model down to about 2/3 the way. You can see the groundwater well here is also dropping. And now if you keep an eye on the lake, you'll see how if the groundwater in a region drops, the lake level will also drop with it. This is really important when you're looking into contaminants, because if there were any contaminants out in the center of this aquifer, they're going to be pulled towards the region where there's a low groundwater level. Here we'll show, we can see that the lake, just in this short time period, has dropped roughly an inch in our model. But that could be several feet in a lake. And here we're going to show you what it looks like to have a contamination plume working its way across the aquifer. We're going to put dye, our contaminant, into this well, and then you can see the green dye is going to go in, and it's going to slowly enter the aquifer. And if you were pumping out of this groundwater well for your house to get bath water or drinking water, as you pump water out of this well, it's going to draw that contamination plume across the aquifer and into your drinking water source.
And this may not happen very quickly, but it just shows that the buildup over time will still have an effect. As you can see, it's about reached the pumping well, And now the well has accepted the contaminant and is pulling it into the well.
This is a prime example of why we need to be careful where we're storing contaminant on the surface level, because even though we can't see the groundwater and it's invisible by the naked or to the naked eye, it actually does have big repercussions on groundwater resources within a region.
So now that the source of the contamination has been removed from this area, but you can still see the where it has moved to and that it's being pulled out. If the contamination were to continue, there would be a continuous plume of the contamination.
Once groundwater is contaminated, it's very difficult to clean up. It's even difficult on the surface. Once we contaminate surface water, it's very difficult to clean up, and we can see that. So imagine if something is down out of your sight and it's in between different layers and different particles, how much more difficult it could be to clean up and remediate the site.
Here we're going to show you an example of how septic tanks work. We're going to inject a dye into the absorption field of this septic tank, or this modeled septic tank, and you can actually see the dye that's going to get pulled down through the groundwater aquifer towards the well if the sewage that would be entering that absorption field would not properly go through treatment.
And you can see the different path that it takes from a septic tank's absorption field than from a point source in a well or a spill. It's slowly moving down, percolating through along the well.
And now at this point, you can see that the contaminant has moved from the absorption field all the way down near the well casing and is starting to enter inside the screen portion of the well and would be contaminating the water source.
This is more of a simulation of a malfunctioning leach field where it lets it percolate through quicker. But if ideally the absorption field would hold on to those contaminants and allow the waste material would collect and in the soil and naturally filter out and be treated before it would get to a well. So proper maintenance of a septic system, checking it out, getting it pumped so that there's not a lot of residual wastes in it are good ways. So to summarize this up, we have a model that shows how surface actions will go down into the subsurface and how other surface actions like pumping or droughts can influence where the plume moves.
In preparation for World Water Day, the Project WET Foundation is offering up several different activities to help you learn and teach about groundwater in the classroom. So we have 3 different activities available on our website, and I would encourage you to check them out. They are both asynchronous and synchronous learning options for you to use in your classroom.